Hi, in this video we are going to see a concrete illustration and example for red-black trees. So let's try to construct a red-black tree from a sorted array. Okay, so let's insert 1. As we have discussed, every node we insert is going to have the color red by default. But this is the root node, and the root node of a black tree has to be black. So we have to recolor it to be black. Okay, then we insert 2. 2 is greater than 1, so it's going to be the right child of the root node, and every item we insert is going to have the red color by default. Maybe we have to change it, but this is how red-black trees work. Okay. So it's going to have the right child of the 1, and it's going to have the color red. Let's insert 3, because basically this is a valid red-black tree. 3 is greater than 1. 3 is greater than 2, so it's going to be the right child of 2. This is the so-called case 3, as we have discussed in the previous videos, because null is considered to be a black node, and the left child of 1 is basically a null, and the null values has the color black. And this is the case 3. We have the newly inserted node 3. The parent of the 3 is a red node as well, and the uncle is the null. And because we have assigned the color black to the null pointers, that's why we are going to end up with the case 3. So we have to make a rotation, plus we have to recolor the nodes if necessary. So we just have to make a left rotation, and as you see we have to make some recoloring, because the 2 is going to have the color red, and we have to make some recoloring. This is exactly the case 3. And it is a valid red-black tree because the root node is black, and the left child and the right child is going to have the color red, so it is valid. Let's insert 4. 4 is greater than 2. 4 is greater than 3, so it's going to be the right child of 3. And it's going to have the red color by default, because this is how we insert items. And this is the typical case 1. The parent of the newly inserted node has the color red, and the uncle has the color red, because the uncle of 4 is going to be the node 1. The parent of 4 is going to be the node 3. So this is the typical case 1. Okay, so we have to color the uncle plus the parent to be black. Okay, so basically this is how we do it. This is the typical case 1 situation, if you may recall. But this is why we have been talking about that we have to check recursively whether it's going to be a valid red-black tree, because we came to the conclusion that it violates the red-black properties again, because after this recoloring, the root node has the color red. And one of the red-black properties says that the root node must have the color black. Okay, so we just have to color the root to be black, because otherwise it would violate the red-black properties. So that's why I said that we have to check recursively that we haven't violated the red-black properties, because for example, after this recoloring phase, we come to the conclusion that the root node is red and it is not valid. We have to color it black. Okay, what if I would like to insert 5? 5 is greater than the root node, so we go to the right. 5 is greater than 3, so we go to the right. 5 is greater than 4, so we insert 5 to be the right child of 4. And because it is a new node, we insert it with the color red. It's going to be the case 3 situation, so we have to make some rotations. We are going to rotate it, and we have to update the colors, as you can see, because the 4 is going to be the root node in this subtree, and instead of the color red, it's going to have the color black. So after the rotation and the recoloring phase, it's going to be a valid red-black tree again. So it's very important that with the help of these 4 cases we have discussing in the previous video, the case 1, case 2, case 3 and case 4, we are able to solve the problem of red-black trees in the sense that we are able to make it balanced. Sometimes you just have to make rotations, and sometimes you just have to recolor some nodes. And basically these cases we have been discussing in the previous videos is going to show how to make these rotations and how to make these recoloring operations. Thanks for watching.